So guys, when we are solving trigonometric equations, right, day one, we're going to look at just some basic examples of what it means to solve this type of an equation. All right, and so mainly today we're going to look at what we call linear equations, all right? Just simple, there's not a ton of detail that goes into it other than the main core idea. But before we do that, I want to take a look at how we connect that to the graphs, all right? So for instance, I'm going to look at f of x equals sine of x, okay? And so if you remember the graphs from last time, we talked about how the graphs were a period or one full section of the graph was divided into 5 sections. Okay, and for sine, we said one full period was from 0 to 2 pi. I didn't do that very well. It's okay. Okay, and for sine, we know that sine of 0, okay, is 0. And we know that sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is 1. And sine of 2 pi is 0. All right, so this is our graph. Okay, now we can use a graph to help us solve these equations because when we graph, we know that the x value is the input, okay, and the y values are the output. Okay, so each of these ordered pairs, so for instance, we have 0, 0. When we know what the x value is, we know the y value is going to be 0. This is the ordered pair pi over 2, 1. This is the pair pi 0. This is the ordered pair 3 pi over 2, 1. And then here we have 2 pi 0. Those are all ordered pairs which give us points on an equation, right? So when I'm looking at this and I'm trying to solve the equation for sine of x is equal to 1/2, okay, what we are doing, what we are asking ourselves is what is the x value for sine when the y value is 1/2, all right? And so how can we use the graphs to help us solve this? Well, let me zoom in. I go up to my graph and I find where 1/2 is. Okay, basically what we're going to do, right, is we are going to look for all of the y values, right, where the y value is equal to 1/2. And so we can see that the graphs cross here and approximately here. Now, if we were to continue this graph, because we know these graphs are continuous, all right, they repeat and they repeat, all right, we can see that ultimately, right, because these graphs go on and on and on, we're going to have an infinite number of solutions, right? So that's why when we start to solve these types of problems, you're going to be in a specific interval on which you want to solve them, right? And so here we are solely looking for the solutions from 0 to 2 pi. So from 0 to 2 pi, where does it cross, right? Well, we can see here and here. Now, the problem with sine, cosine, and tangent is that a lot of our values here, because they're exact values, some of them are kind of strange. Like, we know it's like, especially with radians, pi over 3. Well, what pi over 3? That's like 1 point, and it's an irrational number, right? So that's where knowing the unit circle and being familiar with it is super handy. Okay, so what we want to think of is where on the circle is sine of x equal to 1/2? Well, here we know that there are 2 values, all right? We can see that. We know sine is positive in quadrants 1 and quadrant 2, okay? So what angles give us a sine value of 1/2? Just 1 second. All right, so where is sine is equal to 1/2? All right, sine is equal to 1/2 at 30 degrees and 150 degrees, but because we're going to work with radians because it's 0 to 2 pi, we're going to say that x is equal to pi over 6 and 5 pi over 6, right? So the more familiar you are with your unit circle, the better off that you're going to be in this unit, all right? And so here we're looking at solve the equation for sine of x is equal to 1/2 on the interval -infinity to infinity. All right, so the only thing that we're going to do here is we're going to change it up a little. We're going to say that x is still equal to pi over 6 because that's in that interval. X is also equal to 5 pi over 6. Okay, those are still going to be true. But when we do it from negative infinity to infinity, we talked about in the graph how we're going to have an infinite number of solutions. So essentially what we need to do is we need to identify all of the coterminal angles. Okay, well, we talked about last semester to find a coterminal angle, we have to add 2 pi, right? So 5 pi over 6 plus 2 pi is going to give us the same value, be coterminal, but we can't continuously add 2 pi over and over and over and over again, all right? Because once again, we have an infinite number. So our solution is going to be pi over 6 plus 2 pi n, where n is into any given number of periods. Okay, so you could go 2 periods, you could rotate 3 times, you could rotate 4 times, you could rotate 5 times. N could be any number, any integer, right? And then that would give you a solution. So 5 pi over 6, same thing, plus 2 pi n, where n is any integer. Okay, n is any integer. Okay, so that's the main concept what we're looking for here, right? So when we go to solve these next problems, what we want to do is we're going to isolate the cosine of x. Okay, we're going to get the cosine of x all by itself, identify what that specific trig function is equal to, okay, and then find those specific values in the given interval. So here it's negative infinity to infinity. So what I'm going to do here is I'm going to get I got to combine like terms. So here I'm going to subtract 3 cosine of x. And because this is cosine of x as well, we can combine those. And that gives us 2 cosine of x. All right, plus the square root of 2 is equal to 0. Okay, now we're going to solve for cosine of x like we would solve for x. I'm going to subtract square root of 2. I'm going to divide by 2. All right, so now we're going to look to see where cosine of x is equal to negative square root of 2 over 2. Now, cosine is negative. Remember, it has to be in quadrants 2 and quadrant 3. Okay, this is a reference angle of a square root of 2 over 2. Right, so it's those 45-degree reference angles. So in quadrant 2, x is going to be equal to 3 pi over 4. Okay, and in quadrant 3, it's going to be 5 pi over 4. Right, now, once again, we are looking for negative infinity to infinity. So we have an infinite number of solutions. So it's important, okay, we talked about last with graphs that sine has a period of 2 pi. Cosine has a period of 2 pi. Now, we did not talk about tangent. Okay, tangent, the graphs repeat a little, the period is a little bit less. They repeat more frequently. Tangent only has a period of pi. It repeats every pi instead of 2 pi because it's y divided by x. So you kind of get the same things with the negatives and positives. So anyway, what we're going to do here is we're going to say because it's negative infinity to infinity, that x is equal to 3 pi over 4 plus 2 pi n and pi over 4 plus 2 pi n. Okay, so these are the answers within that given interval from 0 to 2 pi. But because we are looking for all of the solutions, okay, between negative infinity to infinity, we have to add that 2 pi n. Okay. All right, we're going to take a look at a couple more here, just to give other examples. So here I have 3 tan of x equals tan of x minus 2. I'm going to combine my like terms by subtracting tangent of x. So I get 2 tangent of x is equal to negative 2. Divide by 2. I get negative 1. So tangent of x is equal to negative 1. Now remember, tan is equal to y divided by x. So we are trying to figure out on the unit circle here. Okay, and so remember, if we think of our reference angles, I've got pi over 6 is the square root of 3 over 2, 1/2. Pi over 4, square root of 2 over 2, square root over 2. And pi over 3 is 1/2 square root of 3 over 2. Right? So we want to see when I divide the y by the x, it gives me 1. So we know it's that reference angle of 45 degrees, but tangent is negative in quadrants 2 and quadrants 4. Okay, so it's going to be the reference angles of 45 degrees in those quadrants. So it's 3 pi over 4 and 7 pi over 4. Now, because we are only going 0 to 2 pi, we don't have to worry about adding the plus pi in, all right, for tangent. So these are our only answers. Okay. All right, take a look at, now, so this one we have 3 tan of x plus 2 square root of 3 equals 8 square root of 3 minus 3 tan of x, but it's from the interval of negative infinity to infinity. What we're going to do first, we're going to combine like terms. Okay, so I'm going to add 3 tan of x. Those cancel, right? And so right now, where those tangents cancel, we get 2 square root of 3 is equal to 8 square root of 3, right? And what we have here is a false statement. So in this case, there's no solutions, right? There's no solutions for that one. Okay, one more example like this, and then we're going to look at some where we don't have common values. And it's essentially the same thing. We're just going to use our calculator for it. So here I got 4 sine squared of x plus 8 equals 11. Okay, don't let the squared scare you, okay? So it's not that big a deal. So, and then here, we'll just end up using square roots to solve. But here our interval is pi to 3 pi over 2. So if you think about where that is on the unit circle, that is essentially just quadrant 3. Okay, so we're just looking for the angle within quadrant 3. All right, so we're going to subtract 8. So I get 4 sine squared of x is equal to 3. Divide by 4. Okay, then I'm going to take the square root. Okay, so we're going to take the square root of both sides. I get sine of x is equal to, when we take the square root of a fraction, we take a square root of the numerator and the denominator individually, but we end up with plus or minus the square root of 3 over 2. Okay, now, plus or minus is important because if you just put the plus, there isn't a positive square root of 3 in quadrant 3, right? So in this case, because we're specifically looking for the interval in quadrant 3, right, we're only focusing on the negative part, right? So sine of x is equal to negative square root of 3 over 3. That gives us a reference angle of pi over 3, or 60 degrees. And so that's going to be the 4 pi over 3. All right, now, so these next, we have 2 more here. And so there's not a whole lot has changed, but here we have cosine of x is equal to negative 4 over 9. Okay, and negative 4 over 9 is not a common angle, not an angle we find on our unit circle. Okay, and so first off, though, before we start to solve, before we do anything, I want to get an idea. Cosine of x is equal to negative 4 over 9, right? So we know that my answers have to be in quadrants. I didn't put the interval. We're just going to do from 0 to 2 pi. All right, they have to be in quadrant 2 and they have to be in quadrant 3. Okay, so what I'm going to do is I'm going to pull up my Desmos. I'm going to pull up my little calculator here. Let me find. Let's do it this way. Okay, so basically what we're going to do is to solve, we would do just like we would a fraction, like if we were solving a right triangle for an angle. And we're going to say x is equal to cosine inverse of negative 4 over 9. Okay. So I'm going to go to functions on the Desmos, cosine inverse of negative 4 divided by 9. Right. And I get 116. I get 116.3878. Now, this is great, okay? But, okay, there are a couple issues with this, all right? This is my angle. How do I use this to find quadrants 2 and quadrant 3? Okay, well, so 116, we know it rotates around into quadrant 3, okay? What we want to know is we need to figure out the reference angle. Okay, so I'm going to take 180 and I'm going to subtract 116.39. Okay, so that gives us 63.61. Okay, gives us 63.61. So that's my reference angle. So quadrant 2, we know the angle is 116.3878. But in order to figure out what the angle in quadrant 3 is, we need to know that same reference angle. So I need to rotate it 63.61 more degrees. All right, so basically we're going to take 180 and add 63.61. So that we end up, for my other angle, with 243.61 degrees. Okay. All right, so let's take a look at one more of those. You got tangent of x is equal to -3. Tangent is negative in quadrants 2 and quadrants 4. Okay, so I'm going to solve for x first initially by saying tangent inverse of -3. So we do tangent inverse -3. Okay, and so I get a negative 71.56. Okay, now here I'm going to go. I forgot to put. We're going to find from the interval from 0 to 2 pi. Okay, now this answer is fine, but if we think of this angle right here, that is not issue. We'll fix it on the next one. I had it in degrees. We want it to radians, so it's a negative 1.24. So that's a big. So here, if your interval is given in radians, you want to make sure that this is in radian modes, and that was my bad on that one. Right. So here, my radians is a negative 1.249. Now, just keep in mind when you think of radians that pi is 3.14. So read it to that 3.14 here. Okay. So either way, or if you want to do it in degrees and then convert it to radians in the final answer, if the degrees makes more sense. Okay. But either way, we know that this right here is about 3.14. Okay, if we think of it in terms, half of a pi is 1.7. Okay, so if I'm at a negative 1.29, that puts us right about right here. Okay, so either way, that's a negative 1.249. The reference angle here is 1.249. It's the acute angle made with that x-axis, right? And so what we need to do is we need to find the positive angle measurements in quadrants 2 and in quadrants 4. Okay, that have those same reference angles. So in this one, we're going to take pi. For quadrant 2, I'm going to take pi. Right, and I'm going to subtract the 1.249. And in quadrant 4, I'm going to take 2 pi and subtract 1.249. Okay. So this one we get approximately. So here, where they're giving us that approximation, we can go ahead and do the approximation as well. We'd say x is approximately 1.89, and here x is approximately 5.03. Okay, so we have our two solutions there. All right, guys, and that's it for today. I'll still be on Zoom if you need help with it.